Okay, so at the end of the last video, we were talking about this is the lens in the headlights of a car, right? So this would be the light bulb in behind, and it's set so that it's at F for the lens that's in the headlights. And so when the rays, the light is emitted from the light bulb, comes out, and they come out parallel. And they come out parallel, which is a wonderful thing, so that when the cars approach them, they don't see an image of a light bulb hanging out somewhere in front or behind the car. That would be really distracting. All right, case 5. Where do you use a lens, so a convex lens, so that the image that you see is larger than the original object, but on the same side of the lens as the object, and then upright? This one is a magnifying glass, right? If you've ever used a magnifying glass, then you will know that the image is on the same side, right? Imagine reading a book and the image being like closer on above the magnifying glass rather than below. The words are always below, and they're always bigger, and they're always right side up, because otherwise you'd have to hold your book upside down to read it, and that would just be weird. And then this one, where do we use a lens where the image that we get is tinier than the object? Okay, and this one, not as many obvious cases. So they're often used in double lens systems that we'll talk about in our next video, like in a telescope maybe, or a microscope maybe, in some people depending on their eyesight, in glasses. Okay, and again we'll talk about that when we do the eye. Okay, so not as concrete a cases as these ones. All right, so there are our cases for our lenses with our pretty colors. The one last thing, I promised that I would come back. I said in a minute I'll come back and do the rays for a diverging lens. So a few videos ago we were looking at this one, which was a converging lens, and we had 5 rays. One going in parallel to the principal axis, comes out through F. One going in through the optical center, doesn't get bent. And one going in through F gets refracted so that it comes out parallel to the principal axis. Okay, so for our diverging lens, which is a concave lens, really there's only 2 we use. The third one is too complicated. So here's your F, here's your 2F, and I already gave you a sneak preview of these because we use them in the one case over there. Alright, so we draw our object here somewhere, and there are 3 rays. Oh, I just use the top point of the object, don't I? So we'll just use the head. So the first ray that I'm going to use is the one going through the optical center, because it's the easiest one. A ray going from the top of the object, passing through the optical center of the lens, passes straight through without it being bent. Okay, so that one's exactly like the converging lens. A ray going in parallel to the principal axis is going to get refracted in such a way, and I need a bigger lens here. Made my image or my object too high. It's going to get refracted in such a way, bent in such a way, it's going to bend up, and it's going to go up like this. Okay, and if we follow it back, it will look like it was coming from F. Okay, so a ray going in parallel to the principal axis gets refracted in such a way that it appears to come from F on the same side of the image as the object. And then the third one we don't use, and we don't use it because it's funky. Because it's a ray that comes out parallel to the principal. Yeah, no, I'm not even going to do it. It's too complicated. Okay, never mind. All right, so the last piece is, why is this one called a diverging lens? It's called a diverging lens because all rays that go in parallel to the principal axis are all going to get bent in such a way that they diverge on the opposite side of the lens. But if you follow them back, they will all appear to come from the same point. And that point is the focal point. Okay? Whereas the converging lens, the convex, rays that go in parallel to the principal axis, all get bent in such a way that they pass through F on the other side. They converge at F. Okay, so people always say to me, well, why can't we just call the same one that was converging for mirrors converging for lenses? Because rays going in parallel do not converge for a concave lens, they diverge. And rays going in parallel to the principal axis converge for a convex lens. So it's the opposite. For mirrors, the convex mirror causes them to diverge. But for lenses, a convex lens causes them to converge. Okay, so tomorrow we'll look at what happens if you have double lenses. We'll look at some problems with lenses, and maybe we might get to the eye, or that might be the next day. Okay. Oh, homework. Sorry, almost forgot. So homework would be, just in case you don't look at what I print, page 383, and I know, not homework, suggested problems, 17 to 20. And page 389, 12 to 16. And all of these are with lenses, okay? 383, 17 to 20, 389, 12 to 16 are your suggested problems for this evening. Thanks.